So we should now feel comfortable with the sine, cosine, and tangent trig ratios that we can go through and actually apply them to more complicated problems. Aren't you excited for that? Okay, so first of all, what I wanted to start off with is taking a look at our 30, 60, 90 triangle and our 45, 45, 90 triangle. And if I divide all the sides by x, we end up getting these ratios of 1, 2, and square root of 3, and then 1, 1, square root of 2. And I divided everything by x because if we were to write it as a ratio, the fraction that you would come up with, the x's would cancel out anyway. So why not just get rid of the x's for right now, since we're going to reduce in the end. What's nice about these two specific triangles is that if we ever wanted to know what the sine, cosine, or tangent is of 30 degrees, 60 degrees, or 45 degrees, we already have this triangle with all three sides created for us. So we can just look at these numbers and write the appropriate ratio. For example, if I wanted to know what the sine of 60 degrees is, well, I just look at my triangle here with the 60 degrees. Sine is opposite over hypotenuse, so it's going to be root 3 over 2. Likewise, if I went over here to, say, 45 degrees, and I wanted to know what the cosine of 45 degrees is, well, that's opposite over hypotenuse, adjacent, same thing, it's 1, right? But it's still technically adjacent over hypotenuse. And I know that looks like, oh, it should be 1 over root 2. But if you rationalize the denominator, then you get root 2 over 2. Remember, you should always rationalize your denominator. Okay, so what happens if they want you to figure out the sine, cosine, or tangent of an angle that's not 30, 60, or 45 degrees? Well, this is where our calculators come into play. So if you guys all have a scientific calculator, you need to get it out. Or if you don't have a scientific calculator, you need to get one. And you'll know that it's a scientific calculator because it's going to have the sine, cosine, and tangent buttons up at the top somewhere. Okay, so what you're going to do is you're going to actually evaluate what the sine, cosine, and tangent are of specific angles. So for example, the sine of 51 degrees. Now you have to figure out, do you plug in the 51 and then hit the sine key? Or do you hit the sine key and then hit 51 and then enter or equals? You'll have to figure out how your particular calculator works, and you'll know you got it right if you get 0.7771. And I know it keeps going, it's a really long decimal, so we typically abbreviate our decimals to 4 decimal places when we're dealing with sine, cosine, and tangent. Okay, so test it out, make sure that that's what you got, and you know how to plug these things into your calculator. Let's try the tangent of 14 degrees, which is 0.2493. And the cosine of 48, which is 0.6691. Now, if any of you have tried this on your calculator and you're getting the wrong answer, completely wrong answer, what you need to look at in your window is to make sure that you are in degrees and not in radians or gradians. There's different units of measurement for angles, just like we could measure side lengths in meters or feet or yards. There's different ways to measure angles, and it could be in degrees or in radians or gradients. And so it's really important to make sure that you are in the degree setting and not in the radian setting. So you might see a DEG or an RAD or a GRAD. Maybe it's just a letter D, R, or G. But there should be a button to toggle between the different settings. So just make sure that you're in the correct setting, and it only affects your trigonometry that you do on your calculator. Okay, so now that we all are very good at plugging these into our calculator, let's take a look at a problem. Say we had this triangle, and they've given us the measure of this particular angle down here is 38 degrees. We know it's a right triangle. We're looking for this side, and they've given us the hypotenuse is 145. So what we're going to do in this case is we're going to come up with an equation, a trig equation, based off of the information that we have. So we're going to use this angle. We're looking for the opposite side, right? It's just opposite the angle. And we have the hypotenuse. So you have to ask yourself, which trig function deals with opposite and hypotenuse? And hopefully you guys are thinking sine. So what that means is that we're going to write this equation that the sine of 38 degrees, this angle right here, is equal to x over 145. And so now we're going to just use our calculator. You're going to figure out what the sine of 38 degrees is. That's going to be a decimal. And then to get x by itself, we're going to cross multiply. So we're going to multiply these two numbers together and solve for x. So x comes out to be 89.3. Now technically, if you want to get the most accurate answer, when you hit the sine key for the 38 degrees and you get this decimal, you should keep that decimal. It's like a really long decimal. You should keep that in your calculator and then just go right ahead and hit times 145. You'll get the most accurate answer. But if you don't do that and you round to 4 decimal places here and then multiply, you'll get something that's close to it, hopefully close enough for what we need. Okay, but technically if you want to be the most accurate, keep everything in the calculator and round at the end. Okay, hopefully that makes sense, because now we're going to switch gears. We're going to go do something a little different here, still with trig though. So what we're going to do now is talk about taking the inverse of sine, cosine, and tangent. And the way that they represent the inverse is with the little -1 as an exponent. So if you ever see sine raised to the -1, that's sine inverse. And if you know what negative exponents technically mean, this is not a negative exponent technically. This is a symbol to represent inverse. And that's the most annoying thing about mathematics, is that they use the same symbols to mean completely different things. So you have to kind of read the context of what it's written in, right? Kind of like English. Okay, so what are we going to do with these inverses? Well, what you can do is kind of work backwards. So if they tell you the sine of a specific angle is a decimal, and they want to figure out what is that angle, you're going to take the sine inverse of this decimal and it will tell you what that angle is. So remember, we're calling these inverses, so it undoes the function. So it's like subtraction is the inverse of addition, and division is the inverse of multiplication, and taking the square root is the inverse of squaring something. So sine inverse is the inverse of sine, obviously. So on your calculator, you should try to find these buttons, and they typically are second function keys, where if you look at your sine, cosine, and tangent, and you look right above it, written above it should be these 3 words, and which that means that if you want to access this key, you have to hit the second function or the shift key before you hit sine or cosine or tangent. Okay, so let's try it out. Where did my answer go? Apparently I did not do this in the right order. Okay, so ignore this for right now. We have the sine of angle A is 0.1736. So what we're going to do is we're going to write this as angle A is going to equal the sine inverse of 0.1736. So figure out, do you hit this, do you input these numbers and then hit second function sine, or do you need to hit second function sine and then type in these numbers? Either way, when you do it correctly, it should come out to be 9.997 something or other, which would round to 10 degrees. Okay. Okay, so test that out. Make sure you know how to work that on your calculator. The next example, we have the tangent of angle B is 7/4. Now sometimes they don't give us this number as a decimal yet. They give it to us as a fraction. And that's okay, because the first thing that we're going to do is we're just going to convert 7/4 into a decimal. And now, because we're looking for what angle B is going to be the tangent inverse of 1.75. So you hit the appropriate keys, and we end up getting 60.3 degrees, roughly. Okay, so why are we doing this? Well, let's take a look at this example here that we have. They're asking us to find 2 different things. One is to figure out the measure of angle F, and 2 is to figure out the length of DF. And it says do not use Pythagorean theorem, because technically we could, right? This is a right angle. I know I didn't write the little right angle symbol. You can draw that in yourself. But you could figure out this side using trig instead of Pythagorean theorem. But before we do that, we need to figure out what the measure of angle F is. So if we look at angle F and the two sides that are given to us, this is opposite and this is hypotenuse. So we're going to write a trig function saying that the sine of angle F is equal to 11.2 divided by 20.1. So doing what we did last time in just the previous example, we're going to figure out what this is as a decimal. Okay, so we have sine of angle F is 0.5572. And then the next thing we're going to do is we're going to do the inverse since we're trying to solve for the angle. So angle F is going to be sine inverse of this whole decimal. And hopefully you can plug that into your calculator and check it out. So we get 33.86 degrees. Now it didn't tell us how to round, but you would definitely want to make sure you see how you're supposed to round for each problem. Okay, so now that we know that this is 33.86, we can use that in order to figure out df. Okay, so we're going to say the cosine of 33.86 is equal to df over 20.1. So where did this come from? Well, df is the adjacent side of angle f. And so adjacent over hypotenuse is cosine. So now we know that this angle is 33.86. We can say the cosine of 33.86 is adjacent over hypotenuse. Now, with this in your calculator, you can figure out what that decimal is, and then you can multiply that by 20.1. Okay, so remember, if we want to keep things as accurate as possible, keep this in your calculator when you figure it out as a whole decimal, multiply by 20.1, and you should get 16.7. Okay, so you're going to have a bunch of these problems where you're going to have to be searching for either an angle or a side. And you need to figure out, are you doing the inverse sine or are you doing the regular sine? Are you doing inverse cosine or regular cosine? Okay, then the last thing that I wanted to talk about is the difference between the angle of elevation and the angle of depression, because they're going to use these phrases in your word problems. So angle of elevation means that you as a person or object right here is looking up. You are looking up at something. So your angle of elevation starts from the horizontal line, which is probably going to be the ground or something, and you look up at an object that's above you. And you want to see how many degrees is that. That's your angle of elevation. Okay? Now, angle of depression means looking down. So it's like you're on top of a cliff over here. All right, like we can even draw that as like a cliff, you know, like that, okay? And you're up here and you're looking down at an object, say a boat in the water or a tree on the ground, or maybe it's just your buddy that's hanging out there waving at you. Okay, so when you measure the angle of depression, you're starting off looking straight ahead horizontally, and then it's how far are you looking down. And I only need to make this distinction because a lot of people think the angle of depression is this angle right here. But your angle of elevation and angle of depression should always be angles that are made with a horizontal line. Okay? So you see this is a horizontal line here looking down. This is a horizontal line here looking up. So if we can keep that straight in our head, that will make things a little easier for our word problems. Okay, so as you're working on these, if you find that you're having trouble working your calculator, maybe that's something to ask when you get into class. If I'm there or if my sub is there, you can ask them how to input things into your calculator. Okay? That's it. That's the last section of Chapter 9. Congratulations, you made it.